Hi guys, welcome to Power Performance Engineering 2.5 liter Tech Tuesday. Today we're going to touch on the subject of EGT probes. It's a little bit long, so bear with us here. Hopefully you learned something. So these are our EGT thermocouple probes we manufacture. They're custom made for a 2.5 liter, fit right below the coils. They make the bend here, so basically there's the block, and they easily make the bend around the corner, so you're not hanging up on the coils or any of the cowling or any of that stuff like a lot of the other ones. Stainless braided sheath cable to a K-type connection. One thing you want to be aware of is if you run extension cables, the wires are different in all K-type thermocouples. There is chromal, which is one of the wires, and the other one is aluminal. Both of those wires carry different properties and different resistances. This is actually how this works. So be aware you can't just run two wires to the front to whatever dash you're using. It is not going to work correctly. Next thing is the range of these thermocouples on a K-type is minus 328 degrees to 2,300 degrees. So if you're trying to measure head temp, it's probably about the worst setup you can use. Simply because the temperature range is far too wide to get repeatability as far as air temp, head temp, anything, sub 200 degrees. So touching on that, now we'll touch on kind of the dynamics on how this works. So I can't count how many times I get asked, hey, what should my max EGT be? That's like kind of the wild west of questions. There's no right answer there. And here's kind of the reason why. When we use these on the dyno for calibration and stuff, when we're doing legitimate ECU calibration, it's just one of the tools we use. It's typically not even the primary tool. The primary tool we use is indicated power. So that kind of overrules everything else, and then we'll look at temperature as a function of the rest of the stuff. So typically what we're looking for, especially if we do this on AIM and we're looking at a download and a recording, biggest thing I'm primarily looking for is a delta difference between the two. Typically less than 100 degrees. When I say less than 100 degrees, I look at anything above 3,000 RPM should be less than 100 degrees. At idle, you kind of get a little bit of splatter. You might get water reversion coming up the back of the exhaust, changing some things. But typically, if I have a 100-degree difference between the two banks, then I have a problem I need to chase down. Ideally, it's 20, 30 degrees, and they both trace each other up the curve, and they're tight all the way through. If one bank's down, that's typically the bank I would look at, and I'm looking for what it did in the past as to what it's doing today. So whichever one wasn't the same as in the past is the one I'd be primarily looking at first. Other things that influence EGT temperature, if you retard the ignition timing, the EGTs will typically go up. That's typically the largest change you're going to see in EGTs. You can just retard the timing and see the EGTs go up 150 degrees. So same applies when you advance the timing. You advance the timing, the EGTs will typically decrease. Compression is the other one, high compression. The higher the compression, the lower the EGT. The lower the compression, the higher EGT. That's simply related to the thermal efficiency of the engine. You're extracting more power with a higher compression out of the same amount of fuel. So hence EGTs are lower because the combustion is taking place in the chamber, not as it's blown by the probes. Load's the other one that changes. If you put a big propeller on, typically you'll see a big change in EGT versus a small propeller, same thing. When everything is correct, when your air-fuel ratio is correct, which would typically be referred to as stoichiometric air-fuel ratio, when everything is correct on these things, for doing this for the last 30 years, if you take one number out, in other words, you take 1% of fuel mass out of the ECU, typically you'll see a 10-degree increase in EGT temperature, assuming the only way to really see that is on like AIM and you're recording this. And then when you go the other way, if you richen it up, it'll go 10 degrees cooler. So if you see the opposite of that, that means you're on the rich side of stoichiometric, which would make it, you're, like I said, you're rich, basically. So on the rich side, it works the opposite as it does when if your ratio is correct. The other thing you can do too, one thing, a little diagnostic thing, sometimes, you know what I mean, these things get old and you might have issues, whatever. Easy test is, we're looking for ambient temperature when it's sitting, you know what I mean, just plugged in. You're looking for your 100 degrees, 90 degrees, whatever it is, wherever you're at. The other thing you can do is switch this side for that side. Or the other thing, which is a good reference also, which I'd tell you to do, especially if you're racing this thing and you're looking for consistency, take your old school cigarette lighter, pull the probe out of the motor, hit it. You'll typically see, the same temperature every time, but typically you'll see around 600 degrees. So if you're not seeing that and then it cruises back to ambient pretty quickly thereafter, you got a problem somewhere. If you see 2,500 degrees, that's obviously typically a burnt probe or something like that, or if you see 0 or an oddball number. I think that's pretty much it. Like I said, no set number. There is no number that's, hey, I need my GTs at 1124 degrees. That's not a thing. So we do use that. We do use a number off the dyno. When we test them on the dyno and we put them on the boat, we can reference that number, but without that dyno test, you're a little bit out to lunch. Anyway, I hope you enjoyed this. Be sure to check out popperformanceengineering.com. Thanks.